combinations. So combinations is an important topic. We'll see its concepts with all the important questions that has occurred in the previous year's question papers. This one is a important topic for those who are taking discrete mathematics exam, and also for all the placement training, aptitude exams, any aptitude exam. This is an important topic. So now let us see what is combination. We have already learned what is permutation. Permutation involves selection and arrangement, right? So combination is only selection. Here it is only selection. We are not going to arrange them. It is just the selection. Okay. So what type of questions do you have to solve using combination technique is whenever you are supposed to form teams, you have this many boys and this many girls, and you have to form a committee of 5 members where you have to select 3 boys from a team of 8 boys, and you have to select, say, 4 girls from a team of 5 girls, something like that. So whenever you are forming a team, forming a committee, or you might have seen questions like there is a box with this many colored white balls, 5 red balls, 6 green balls, 3 white balls. In how many ways you can select this many balls, such that all balls of some color. So these kind of questions all come under combination. So basically combination is only selection. Here, this is number of selections or number of ways. You can make a note of this. Number of ways of selecting R objects out of n objects. R objects out of n objects. This is combination. It is denoted using NCR. It is denoted as NCR. Number of combinations of R out of n objects. Now let us see the formula for NCR, and there are some standard results for NCR, which is very important in order to solve the questions that comes under this topic. So let us see all these one by one. So the first one is write down all the formulas. NCR is equal to n factorial divided by r factorial into n minus r factorial. This is the formula for NCR. Okay. So if you observe, n factorial by n minus r factorial is nothing but the formula for permutation, right? Permutation formula is n factorial by n minus r factorial. Here you have extra r factorial in the denominator. So you can also write NCR as NPR divided by r factorial, because n factorial by n minus r factorial is nothing but NPR. You are dividing it by r factorial to get the number of combinations that are possible. So how to write, how to simplify? Let us see few examples and let us see how to simplify them. So first example, I will take 10C3. 10C3. Here 10 is n and r is 3. So n factorial is 10 factorial divided by R factorial means you have to write 3 factorial, and then you have 10 minus 3 factorial, which is 7 factorial. Now you know how to simplify this. Expand the bigger factorial until you reach one of the smaller factorial so that it gets cancelled. So I am expanding this 10 into 9 into 8 into 7 factorial. I'll stop here because denominator has a 7 factorial which will get cancelled. And then here I have 3 factorial, right? I'll write its value, which is 6. So 7 factorial gets cancelled. We'll cancel this by 3. 3 2s are 6 and 3 3s are 9 and 2 4s are 8, which gives you 120. So this is how you simplify, you find out value of 10C3 using formula. But every time you don't have to write the formula. We had seen a direct way of writing NPR, right? So whatever is given, like if it is 10P3, we should write 3 numbers from 10 in the decreasing order, which is 10 into 9 into 8. Now that NPR is further divided by R factorial, we will write 10C3 as 10P3 by R factorial. What is 10P3? Write 3 numbers from 10 in the decreasing order. 10 into 9 into 8. This is your permutation. Divide this by R factorial to get combination. So basically we are getting this point. We are getting to this point without substituting the formula. It is acceptable even in descriptive answers. So you don't have to every time substitute the formula and write. In your solution, in a step, in the final step, if you are getting something like this 10C3, you can directly get the answer as 10 into 9 into 8 by 3 factorial, then cancel and get the answer as 120. Okay. So this is how you simplify. Now let us see some of the standard properties of NCR. Um, Properties, or you can write standard results. Of NCR. Okay. These results again are important. We are going to be using them in our problems. I'll tell you where to use which one, and you don't have to memorize it. If you understand why certain values are there in the standard results, it is easier to apply them in solving your questions. So the first one is NC0, means there are n objects and you're selecting only 0 objects out of this. So NC0 value is 1 and NCN is 1. So if you are selecting 0 objects or if you are selecting all objects, then answer is 1. Suppose you are selecting only one object, then the answer is n. Or if you are selecting all objects except one object, then also the answer is n. So I will write examples in the side to make you understand this easily. Now NC0 is 1, right? So I'll write 5C0. Irrespective of this number, 5C0, if you have 0 here, it's going to be 1. Similarly, if you have 6C6, if these two numbers are equal, then also it's going to be 1. Okay, this is example for the first result. For second result, suppose you have 5C1. That is, if R is 1, then whatever is n, it is going to be your answer. You can find out this by substituting in the formula. This is what you're going to get. But you don't have to, these are not shortcut tricks. These are standard results, which are completely valid to be used in your descriptive solutions also. Okay. And if you have 5C4, that is, if R is 1 less than n, then also the answer is 5. So what will be the answer for 8C7? Give me your solutions in the chat so that it is more interactive. HC7, what's the answer going to be? R is 1 less than N. So what will be the answer? No one. NC N minus 1. If R is 1 less than N, the answer is going to be N itself. Okay. So here the answer is 8. So remember, if R is 1 or Kirtana has given the answer 8. Correct. So if R is 1 or if R is 1 less than N, the answer is N itself. These results are very important in solving solutions. If you don't know these results, every time if you substitute in the formula and find out, it is going to take so much of time. Okay. So make sure you are understanding these results. So these are the first two set of results. Next is, if NCX is equal to NCY, write down other result, then we will write this. NCR is equal to NCN minus R. This is very important. This result we are going to use in many problems. Okay, NCR is equal to NCN minus R. So in the denominator of NCR formula, you have R factorial and N minus R factorial. So I've told you how to write 10C3. For 10C3, you have to write 3 numbers from 10 in the decreasing order and then write 3 factorial in the denominator, right? Suppose if I give you 10C2, it is easy. Write 2 numbers from 10 in the denominator, which is 10 into in the numerator, which is 10 into 9, divided by 2 factorial is 2. This is 90 by 2, 45. If I ask you to find what is 7C3, write 3 numbers from 7, which is 7 into 6 into 5. Then write 3 factorial in the denominator. Okay, R factorial in the denominator. This many numbers from N in the numerator. Now 3 factorial is same as 6. This gives you 35. So this is easy. You can get the answer quickly. Suppose the value is like 15C13. The combination that you are supposed to find is 15C13. Then you cannot write 13 numbers from 15 in the decreasing order. Then divide by 13 factorial. It's going to be very lengthy. In such situations, what we do is, whenever R is a big number and close to N, we take the difference in place of R. So this is same as 15C. Take the difference of these two. 15 and 13 difference is 2. 15C13 is same as 15C2. Therefore, it's easy now to find out the answer. You can get the answer quickly. 15 into 14 divided by 2 factorial is 2 only. So 2 sevens are. This is 70 plus 35. 105. 105 will be the answer. So you can use this NCR equals to NCN minus R. You can try substituting this in the formula. You will know why we are using this. Basically, once you apply the formula, you're going to get the same thing. That is the reason. Say if I take 15C13, if I substitute in the formula, I will get N factorial divided by R factorial is 13 factorial. N minus R is 15 minus 13, which is 2 factorial. I'm not going to simplify this. Suppose if I try to find out what is 15C2, again N factorial is 15 factorial. divided by r factorial is 2 factorial, and then n minus r factorial is 15 minus 2, which is 13 factorial. Okay. If you observe, numerator has 15 factorial, denominator is 13 factorial into 2 factorial, which is same. Therefore, we directly use this result. Whenever r is a big number, we will write down n minus r in place of r and make the simplifications easier. Hope it is clear. Next, we will solve. This is one property. Next property is, if it is given that ncx is equal to ncy. Observe, if ncx is equal to ncy means n is same, r is not known, and they have given it is equal, then only two possibilities are there. Either x and y are equal. Okay. So since n is equal and this combination is equal, of course x and y should be equal, right? Or x plus y it can be like this also, like 15c3 is equal to 15c2. Here this number and this number are not equal, but these two together is equal to 15. Or x plus y is equal to n. Okay, understand this clearly. If two combinations are given as equal and if n is same, then either these two r values should be equal or together it should be equal to value of n. Right? So this is another property. And then we have one more property. The last one. That is NC1, basically NC naught plus NC1 plus NC2 goes on up to NCN is equal to 2 power n. This is the actual result where the possibilities of 0 or more combinations or 0 or more selections, then you will use this formula 2 power n. Okay, this is when in the question they have given 0 or more selections. 0 or more selections. Okay. If it is given 1 or more, then 0 you should not consider. NC0 you're not considering because it has to be 1 or more. Means minimum he should select one object. If you are selecting one object, number of ways is NC1. If you're selecting two objects, NC2 goes on up to NCN. So this entire thing is 2 power n. From this, you're removing NC0, or you can consider this as taking NC0 to the right hand side. What is value of NC0? 1, right? So it is going to be 2 power n minus 1. So when are you going to use this? Whenever they have given one or more selections. In the question, if they have given one or more selections, then the answer is 2 power n minus 1. If they have given 0 or more selections, the answer is going to be 2 power n. 0 or more selections is usually very rare. Okay, this is very rare and this is very common. They might ask you, like, a person has 8 friends. In how many ways he can invite one or more of them to his birthday party? In such case, he has 8 friends, right? So n is 8. The number of ways in which he can invite one or more of his friends, it means he can invite one friend, or he can invite two friends, or he can invite three friends, or he can invite all the friends also. So, which is nothing but NC1 plus NC2 up to NCN. for which you don't have to find out all these combinations. Directly find out what is 2 power n minus 1. So it is 2 power 8 minus 1. 2 power 8 is 256 minus 1 is 255. Okay, so this will be the answer. There are 255 ways of inviting one or more friends to his party. Now we'll solve some questions based on this. These are the combination concepts. That's all is combination concepts. There are few special cases. We'll see how to solve them. Otherwise, there are too many varieties of questions that can be asked. You need to know how to solve each type of question. Let us solve the questions one by one. I will take the questions from among 20 members of a team, there are 2 wicket keepers and 5 bowlers. In how many ways can 11 persons be chosen to include only 1 wicket keeper and at least 3 bowlers? Okay, understand the question clearly. Team has totally 20 people. In this, 2 are wicket keepers, 5 are bowlers, and remaining people are all-rounders, right? So first, divide them into categories. So we have wicket keepers, and then we have bowlers, and then we have all-rounders. Okay, all-rounders or batsmen, whatever, you can consider your third team, you can consider whatever you want. Now, how many wicket keepers are there? 2. How many bowlers are there? 5. And how many other people are there? Totally, we have 20, right? So 2 plus 7 is 2 plus 5 is 7. So there are remaining 13 people here. Now, in how many ways can 11 persons be chosen? So you need to choose a team of 11 people such that it should include only 1 wicket keeper and at least 3 bowlers. Okay, understand the question. Now, this is the team categorization. These are the 3 groups, and I need a team of 11 members. I need exactly 1 wicket keeper, which is 1 here I'll write, and I need at least 3 bowlers. So, bowlers can be 3 or more. So I have 3 bowlers I can choose, or I can choose 4 bowlers, or I can choose all the 5 of them. Accordingly, in each of this case, wicket keeper must be only 1. Okay, only 1 wicket keeper. Now, for to make a team of 11, how many more do you need here? That you write down. So we have 1 wicket keeper and 3 bowlers, which is 4. So I need 7 people from this group. 1 plus 4 is 5. So I need 6 people from this group. 1 plus 5 is 6. Now I need 5 people from this group. Hope it is clear. Wicket keeper must be only 1. So I have written 1 here. Bowlers must be at least 3. When we say at least 3, it can be 3 and more. So I've started from 3. It can be 4. And it can be 5 bowlers also. According to this number, I have written how many all-rounders must be selected so that the total is 11. Okay. Now we will write in how many ways you can do this combination. Out of 2 people, you need to choose 1 person, which is 2C1. Okay. Into. Out of 5 bowlers, you need to choose 3 people. So 5C3 into. Out of 13 people, you need to choose 7 people, which is 13C7. Find out the answer for this. That gives you the number of teams in which there is 1 wicket keeper, 3 bowlers, and 5 all-rounders. Similarly, find out for the remaining. Here again it is 2C1 into 5C4 into 13C6 and here it is 2C1 into 5C5 into 13C5. So let us find out the answers and write here. 2C1 is 2, 5C3 is 10. You can find out what is 5C3. Do these calculations in your rough column. So 5C3 is 3 numbers from 5, which is 5 into 4 into 3, divided by 3 factorial is 6. So 4 3s are 12. So 6 2s are 12. This gives you 10. Okay. Into, next we need to find 13C7. 13C7 is, write down 7 numbers from 13, which is 13 into 12 into 11 into 10 into 9 into 8. 1, 2, 3, 4, 5, 6, and then 7. Okay. And then the denominator, write 7 factorial, which is 7 into 6 into 5 into 4 into 3 into 2 into 1. I'll just stop at 2. Now cancel this. 4 3s are 12 gets cancelled. 5 2s are 10 gets cancelled. And then we have 7 and 7 gets cancelled. I will cancel this by 2. 2 3s are, 2 4s are. And then this 3 is cancelled with this 3. 9, 3 1s are, 3 3s are. So what do I have? 13, 11, and then 3 and 4. That's it. So what is the value? This is 13 into 11 into 12, which gives you 1716. So this should be in your rough column. So this is 1716. So this is equal to 1716 into 20, which is 34320. Now the next line, 2C1 is 2, 5C4, R is 1 less than N, right? So you're going to get 5 here. 13C6 is same as 13C7 because 13 minus 6 is 7, which is same as this. Therefore, this is also 1716, which is equal to 1716 into 10 is 17160. 17160. Here 2C1 is 2 into 5C5 is 1 into 13C5 is 5 numbers from 13 divided by 5 factorial. 13 into 12 into 11 into 10 into 9. 5 numbers divided by 5 factorial, which is 5 into 4 into 3 into 2 into 1. So 4 and 3 gets cancelled with 12. 5 and 2 gets cancelled with 10. So you have 13 into 11 into 9. Which is 1287. So this is 1287. And the answer is 2574. Now all this you need to add. That gives you the required answer. Find out the sum of this. We have 34320 plus 17160 plus 2574, which gives you 54054. This many teams are possible. The calculations are quite bigger. You won't get this big calculations. Even if you get, you can use a simple calculator and you can do the calculations. It's not going to be difficult. Hope it is clear. When you have total people and there are multiple groups, first write down the groups and see what are the restrictions given. Accordingly, write down how many people you need to select or how many objects you need to select from each of the groups, and write the combinations for that and multiply them. Each of this answer you need to add. That gives you the answer. Now let us. So this is from June 2011. So a question paper has two sections, means we have two groups of 5 questions each. So section A has 5 questions and section B has 5 questions. Okay, each groups we have written. And totally we need to answer 6 questions. So the total questions to be answered, right? To be answered is 6. We need to take at least 2 from each group. So take 2 from this. Now how many should you write here? 4 to make the total as 6. Now take 3 from this group. If you're writing 3 questions from this group, then you need to write 3 questions from here also to make it 6. Can you write 4 questions from this group? Yes. If you write 4 questions from here, then you will write 2 questions from here to make it a total of 6. Now, can I write 5 questions from here? No. If I write 5 questions from first section, then from second section, I need to choose only 1 because total to be answered is 6, which is not possible. They have given at least 2 in each group. So minimum 2 should be there in each of the groups. Hope this is clear. I've taken 2 questions in the first section. Accordingly, I've written how many in the second section. Similarly, I've written 3 questions in the first section, 4 questions in the first section. This has covered minimum question category for second section also. Now we will write each of these combinations. From 5, you need to choose 2 questions from first section into. From second section, out of 5, you need to choose 4. Here, from 5, choose 3, and from second section, choose 3. In this, from first section, out of 5, choose 4, and from second section, out of 5, you are choosing 2. Now 5C2 is 10, 5C4 is 5. Here 5C3 is also 10, 5C3 this is 10, which gives you 100. Now 5C4 is 5 into 5C2 is 10, which is same as this if you have observed. So this is 50. So the answer is 200. There are 200 different ways in which a student can answer 6 questions by choosing 2 out of at least 2 out of each group. This is from December 2011. If there are 12 people in a party, if each 2 of them shake hands with each other, how many handshakes happen in a party? Now, for each handshake, 2 people is required for the handshake. Order in which it is done is not important. So, number of people is 12, and number of people required for a handshake is 2. So, number of handshakes, this is a standard question. Number of handshakes is 12C2, which is 12 into 11 divided by 2 into 1. This is 66 handshakes are possible. Okay, 66 handshakes should happen Now, and you can also solve it without combination. That is, there are 12 people. Each of them should shake hands with each other person. So, one person, if you take one person, then there are remaining 11 persons, right? There are 12 people. If you are part of that party, you are one of them, and there are 11 other people. And when you are going to that party, you have to do a handshake with all the remaining 11 people. So number of handshakes done by each person is 11. Okay. If not like this, you can solve it as number of handshakes done by each person is 11, because each person it's not 12, because a person does not do a handshake with himself, right? It is only with all the other people in the party. So each person does 11 handshakes with all the remaining people. Like this, if you count the number of handshakes done by each of them, there are 12 people, right? Number of people is 12. Number of people is 12. So, total number of handshakes, if you consider, total number of handshakes, it is 12 into 11, right? But here, you are counting number of handshakes from each person, right? You're asking each person how many handshakes did you do, how many handshakes did you do, like that. You're asking for each and every person. Every person says I did 11 handshakes, but then there is people like A, B, C, D, E. Now A says that he has done 11 handshakes, which means he has done handshake with B, he has done handshake with C. He has done handshake with D also. So AB is one handshake. AC is one handshake. AD is one handshake. Now, if you ask B, B also says that he had 11 handshakes, right? In which it includes BA, BC, BD, right? And goes on. Now, this one I have counted twice, right? Similarly, if I ask C, C says that there was a handshake between CA, CB, and CD. In this, CA is already repeated here, CB is already repeated here. So basically, each handshake we are counting twice in this. One from this person and once from this person, right? So this person says AB has a handshake, BA also says hey, BA has a handshake, but actually this was one handshake only. So since every handshake is counted twice in this 12 into 11, because we are counting handshakes from each one of them, right? Therefore, this actual number of handshakes is half of this, which gives you 66. You can give your answer either this way or using combinations. Combinations way is easy to explain. Totally, we have 12 people. That is 12 number of people are there. Number of people required for a single handshake is 2. So out of 12, how many 2-2 combinations can be done? Is 12C2. Okay. It's a 3-mark question, a very simple, straightforward question. Here, find the number of different messages that can be represented by sequences of 4 dashes and 3 dots. It's a combination, permutation-based question. I think I have solved it in the first video, permutation video. You can go through that. And this is also a permutation based question, and it's an interesting one, and I'll solve this. Please note, this is not a combination based question, it is a permutation based question. This is also asked in December 2011. A valid computer password consists of 9 characters. First of which is a digit, 1, 5 or 7. The third character is either a hash or a dollar, and the remaining an English alphabet or a digit. Find how many different passwords are possible. Now, we have 9 characters, right? Let us first write 9 positions. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, how many choices do I have for the first digit? It is 1, 5, or 7. Means the number of options I have is 3. You need to write that as a statement. Number of options available for first position is 3. Okay. And the third character is either a hash or a dollar. Okay. Third character has only 2 options. It has to be one among these two. Remaining is either an English alphabet or a digit. Now, how many remaining options are there? We have totally 9 positions. In that, for these 2 positions, we have specific considerations. There are remaining 7 positions, right? So you have to write first position can be filled with any of the 3 digits in 3 ways. Third position can be filled with either a dollar or hash in 2 ways. And remaining positions, write down those 2 sentences and then you have to write remaining 7 positions can be filled. Always, as I told you, unless and until it is given that we can repeat the digits, we are going to consider that digits or alphabets, it's not repeated. That is what we are going to consider. Remaining 7 positions can be filled with any of the 26 English alphabets. Okay. Because we have not used alphabets now. I have used one of the digits here. In this 3, I have to put 1 digit. I have used 1 digit here. And this is a special symbol. Now, out of 10 digits, okay, out of 10 digits from 0 to 9, one of them is used here. So there are 9 more digits. And English alphabets, none of them are used. So I have 26 alphabets, right? So 26 alphabets and remaining 9 digits. Okay. Because 1 digit is used in the first position, there are remaining 9 digits, which is n is 26 plus 9, 35. R is 7 because I need to fill 7 positions, right? So answer is, or number of passwords that can be formed is 3. This is for the first position into 2 ways for the second position, and remaining 7 positions can be filled in 35p7 ways. Select any 7 out of the letters and the digits together, because there is no restriction. They have not given you have to select this many letters and this many digits. That is not given. All 7 can be digits here. All 7 can be letters or any mixture of letters and digits. So it is 35p7. This is your answer. You can keep it as it is. No need to simplify. Keep it as 6 into 3 into 2 is 6. 6 into 35p7 is your answer. No need to simplify further whenever you have big numbers. This is a 4-mark question asked in December 2011 and it is under permutation. Okay, so the next category of the question is about this joining points. Okay, before learning that, I'll tell you the concept behind it so that you will be able to solve any question um, on these points. So, joining points on a plane. They would have given you n points. There are n points and none of them are collinear. Collinear means points that lie on the same line. Say if I take 5 points, okay, 5 points A, B, C, D, E, I'll take. If the points are like this, no three of them are in the same line, right? They're all in different lines. So these are non-collinear points. Suppose if I say there are 5 points, in that 3 are collinear. Okay, there are 5 points, in that 3 are collinear. It means there are 3 points that forms a single straight line, and there are 2 other points which can be anywhere, cannot be on the same line. We'll put it somewhere like this. Okay, it's going to be like this. Now, if you see, this is one line, this is another line. Though it's not a perfect straight line, right? This is one line, this is one line, whereas this is a single straight line which covers all 3 points. Here, 3 are collinear. So this is the kind of questions you might get wherein they will either give all points are non-collinear, or out of the given points, there will be some collinear points. In this first category is no non-collinear points. Sorry, no collinear points. Means none of the points are collinear. No collinear points. Then, if they ask you how many straight lines can be formed, please observe, if they ask you how many straight lines can be formed, to form one straight line, we need 2 points, right? So, number of straight lines that can be formed. Number of straight lines that can be formed is, there are n points, in that you need to select 2 points. That gives you number of straight lines. Or they might ask you number of triangles that can be formed. So how many points do you need to form a triangle? 3 points are required, right? So NC3 gives you number of triangles that can be formed from the given n points. Okay, this is if no collinear points have been mentioned. Suppose they have given collinear points are also there, means there are n points. Okay, there are n points, out of which m are collinear. Like what I had written earlier, there are 5 points in which 3 are collinear. There are 9 points in which 4 are collinear, something like that. Okay, so these points lie on the same line. Here, how many lines can be formed? First, we find out how many 2 letter combinations can be written, which is NC2. In this, all are not different lines, because say if I take 3 collinear points, okay, 3 collinear points if I take, now this is ABCDE. Now when I write NC2, it includes AB as a separate line, it considers BC as a separate line, and it considers AC as a separate line. And then, of course, we have AD, AE, then BD, BE, and then we have CD and CE. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. There is one more required. I've written AB, AC, AD, AE. BC, BD, BE, DE. DE I have not written. Okay. So if I consider all these things, now the total number of, when I write NC2, it means there are totally 10 different combinations, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But actually, 10 different combinations will be there if we don't have any collinear points. But now here we have collinear points, right? Is AB, BC, AC all separate lines? No. AC is one single line. We have only one line AC. AB and BC are not separate lines. They were part of AC. So what we do, from these 3 points, I have counted that there are 3 different lines, which is wrong. So that I am going to subtract. So let us subtract all the combinations that we have formed from this collinear points. Okay. All these 2 letter combinations that we have formed from these collinear points, we will remove. And all this is equal to one single line. Therefore, we will add 1. Okay, this is whenever collinear points are there, NC2 minus how many ever collinear points C2, because these are not separate lines, they are one single line. I'm removing all of them and then adding the one single line. Okay, that is number of straight lines that can be formed. And in this case, how many triangles can be formed? Again, all three combinations we will first count. In this, all of them are not triangles. From the collinear points, whatever combinations we have counted, we will remove that. Here we are not adding 1 because these points do not form a triangle, they're just a straight line. So remember, +1 is required only if it is number of straight lines. If it is number of triangles, +1 is not required. Just subtract this MC3. This is points on a plane based questions. How many straight lines can be formed? How many triangles can be formed when collinear points are there, when collinear points are not there? Sometimes they will give you how many diagonals can be formed. Okay. For this, you have to understand a polygon of n sides will have n points and it will have n exterior sides. Okay. What is a polygon? All closed objects which have 3 or more sides. So the one with 3 sides, polygon with 3 sides is a triangle. Polygon with 4 sides can be a square or a rectangle or a parallelogram, anything. That is a polygon with 4 sides, means a closed figure with 4 sides. Polygon with 5 sides is called a pentagon. So polygon is basically a closed 2D object like this. Okay. So if you have a triangle, then number of points is 3, right? Number of points is 3. And now how many sides you have? That is also 3. Here you see number of points is 4. I have 1, 2, 3, 4 points. And how many sides does this have? That is also 4. If I draw a pentagon with 5 points, okay. Here how many points are there? 5. And how many sides are there? 5. Right? 1, 2, 3, 4, 5. So a polygon will have how many ever points it has. It will have that many external lines which are its sides. All the lines that are internal are considered as diagonals. So here all these internal lines are considered diagonals. So here we have 2 diagonals. Here I have 1, 2, 3, 4, 5, 5 diagonals are there here. Okay. So basically, when they ask you about polygon, so polygon with n points, has n sides or n external sides or just exteriors, whatever you want, you can write. And number of diagonals is equal to, what will be number of diagonals? See, whenever they give you polygon, no, they will not mention about collinear points. So we are going to assume there are no collinear points. So number of diagonals will be, so totally NC2 is the total number of lines. In this, N are external sides, remaining are diagonals. Okay, so out of N points, you can form NC2 straight lines. In this NC2 straight lines, there are n sides. Those are not diagonals, those are outer sides that defines the boundary of the polygon. All the lines that are inside that boundary are called diagonals. So I am subtracting n, and remaining whatever is that, that is the number of diagonals. So this is the number of this is a different type of questions that you can get under the points category. Now we will solve the question that we have copied. There are 15 points in a plane, no 3 of which are collinear. Okay, they have not given 3 of which are collinear. They have given no 3 of which are collinear, means none of them are collinear. Find number of straight lines formed by joining them. It's a very simple question. They have given 4 marks. If it was an MCQ based, aptitude question or something, answer is just 15C2, which is 15 into 14 divided by 2 factorial is 2. It gets cancelled. This is 70 plus 35 is 105. That's all is the answer. But you can't write just this much for a 4-mark question. So write down clearly. So value of number of points is equal to n, which is equal to 15. So presentation of answer is important to get that 4 marks. Number of points is n, and that is equal to 15. And number of points required to form straight line, number of points required to form a straight line is equal to r, that is equal to 2. Okay, so number of straight lines is NCR or NC2, which is equal to 15C2, and then simplify and write the answer. Even then 2 marks is too much for this. I mean 4 marks is too much for this. Nothing more you can write. This is the answer. Now you know how to solve any type of question that comes under this points, whether it is number of straight lines or triangles, or whether they ask collinear, with collinear, without collinear, or diagonals, anything, you should be able to solve it with these points. So that is about this question. We'll see the next question. This is to June 2012. So here we have a question with just 2 marks. This is a question where you have a bag which has different colored balls, and how to select certain number of balls out of it. This is asked in December 2012. Okay. Is all of you are understanding? I need response. Please give response. Urn is a bag. An urn contains 15 balls, 8 of which are red and 7 are black. In how many ways 5 balls can be drawn such that all 5 are red, 3 are red and 2 are black? So first sub question is all 5 are red. See, the marks is just 2 and you have 2 sub questions. So basically it's just 1 mark per question. So there is no need to write more than 1 or 2 line answer for these things. Okay, so here all 5 are red. I want to select 5 balls and all of them should be red. It means I'm not even considering the black balls. Consider only the red balls. So the answer for this is number of ways or you can write there are how many red balls? 8 are red, right? There are 8 red balls. Number of ways of selecting five red, 5 out of 8 red balls. 5 out of 8 red balls is equal to 8C3. That's all. 8C5. 8C5 is same as 8C3. You can write 8C3 and then simplify this 8 into 7 into 6 divided by 3 factorial. 3 factorial is same as 6. So 8 into 7, 56 is the answer. That's all. This gives you 1 mark. Since I want only red balls, I'm considering only red balls. Now next is 3 are red and 2 are black. So here you write a number of ways of selecting, or you can even write like this, 3 red balls can be selected out of how many red balls do we have? 8. Out of 8 is out of 8 in 8C3 ways. Okay. There are 8 red balls. Out of that, you need to select 3 of them. So in 8C3 ways, and then we need 2 black balls, right? 2 black balls can be selected out of how many black balls do we have? 7 black. Out of 7 in 7C2 ways. Therefore, number of ways is equal to, multiply these two because the question is not select 3 red balls or 2 black balls. Here we need to select 3 red balls and 2 black balls, right? We have and here. So if we have and, we are going to use the multiplication rule. So number of ways of selecting 3 red and 2 black is 8C3 into 7C2. So 8C3 we have already written it is 56 into 7C2 is 7 into 6 by 2 factorial is 2. So this gives you 3. This is 56 into 21. 56 into 21 is 1176 ways. That's all is the answer. Again, 1 mark for this is very less. Okay. Now let us solve the next question. Any doubts? See, question number, this is June 2013. Question number 1, I'm not going to solve it. I'll just tell you how to solve. A carpenter has 12 patterns of chairs and 5 patterns of tables. In how many ways can he make a pair of a chair and a table? So in chair, he has 12 different patterns, right? So number of ways of making one chair is 12, which is 12C1 basically, which is 12. And in number of ways in which he can make one table is 5C1. And here they have given chair and table. So it is 12C1 into 5C1, which is going to be just 12C1 into 5C1, which is 12 into 5, 60. 60 different types of pairs he can form. Next question is this one, which is similar to our first question. And this also carries 4 marks. In how many ways a person can invite 8 of his friends to a party by inviting at least one of them be a female? Considering that the person is having 15 male and 8 female friends. So there are 15 male and 8 female friends. He should invite 8 of his friends only. Okay, he can invite only 8 of his friends, and at least one should be a female. So here we are going to solve it using an alternative method. Understand how to solve this? So there are totally 15 male and female friends are 8. And how many people he can invite? 8. He must invite 8 people. In that, at least one of them should be female. So minimum number of females he has to invite is 1. But it can be more than 1 also. So he can invite 2 females also. He can invite 3. He can invite 4, 5. Don't write this solution. 6, 7, or all 8 females also he can invite. If he is inviting 1 female, then he has to invite 7 male in order to make a total of 8 guests. If he is inviting 2 females, then he has to invite 6 males, so that the total is 8. Here again, if he is inviting 3 females, then he has to invite 5 males. Understood? So so that the total is 8. Like this, if you write, this is 5, 4, 3, 2, 1, and 0. If he's inviting all female friends, then he has to invite none of the male friends. This many choices are there. Okay. And solving this is very time consuming. Now, how to solve this? This is 15C7. Out of 15 people, he need to choose 7 people. And out of 8 women, he needs to choose one of them. This is 15C6 into 8C2. This is 15C5 into 8C3. Now we need to find out what each one of this and then add all of them to get the answer. Okay. But whenever you have at least one, in the question, if you have at least one, for a second, think how many subcases you have here. So there are 8 females. Okay, there are 8 females, and he has to invite at least one of the female, and he has to invite 8 friends. So from 1 to 8, there are 8 subcases here. When you have so many subcases, don't solve it this way. This is a direct method. Don't solve using the direct method. We are going to use the indirect method. So what is indirect method? Now let us understand. So we'll solve the indirect method. You can understand when to use this one. So in this indirect method, now I'll find out what is the total friends he has, right? Total friends he has is 23. 15 male and 8 female. Totally he has 23 friends. In this, how many should he invite? 8. So what are different possibilities are there? Number of ways of inviting 8 friends out of 23 is 23C8. This is the total number of ways. But in this 23C8, what all types of teams are there, or what all types of groups he is inviting? It can be all women group, right? It can be all 8 females he can invite, or he can invite 7 female and 1 male, or he can invite 6 female and 2 male, or he can invite 5 female and 3 male, or 4 female and 4 male, or 3 female and 5 male, 2 female and 6 male, or 1 female and 7 male. He can also have all 8 males, right? All 8 male friends he can invite. These are all different possibilities included in this 23C8. But what are they asking us to find? In how many ways he can invite? At least one of them should be a female. So we are just excluding this. All 8 males category, only this we are excluding. Everything else we are considering. Minimum 1 female, 2, 3, up to 8. All this we are supposed to consider and exclude only this. So in such cases, use the indirect method. In this indirect method, we will find out total ways. Okay. Hope you have understood this. So total ways is find out total friends. In that, how many people you have to choose. That is total ways. And then you just write down how many teams needs to be excluded. Teams to be excluded or options to be excluded, or we'll find out all 7 male friends, or you can write none of the female friends. Okay. None of the female friends. So if he is not inviting any of the female friends, means he's inviting only male friends. How is it possible? I mean, now, what is the number of ways? We have 15 male friends. In that, we need to choose 8 of them, right? It's 15C8. This is the number of teams or number of invites, number of different ways of inviting only male friends where he doesn't invite even a single female friend. So out of 15, since we are not inviting female friends, we are not considering them at all. We are considering only male friends. In that, he has to invite 8. This is all men invitation, right? All males. Now, if I remove this from the total possibilities, then I will have all those teams which has 1 female, 2 female, all 8 females, everything is included in that when I remove this. So, number of ways of inviting at least 1 female. Number of ways of inviting at least 1 female is equal to total ways. From this you subtract all male ways. That gives you the answer. Is it clear? Now you can solve this or even you can keep it as it is, doesn't matter. So I'll try to solve and find out what is the answer. 23 into 22 into 21. I'll just find out here itself. This is 8 numbers we need to write, which is 23 into 22 into 21 into 20 into 19, 18, 17, 16. Right? 1, 2, 3, 4, 5, 6, 7, 8 divided by 8 factorial is 4320, or you'll just write everything 8, 7, 6, 5, 4, 3, 2. Now 4 into 3 is, okay, this doesn't get cancelled. So 4 into 3 into 2. Now 16 is 8 into 2. That gets cancelled. And then I will cancel 4 5s are 20. And then 7 3s are 21. And this 3 gets cancelled with this. I have only 6 left. 6 3s are 18. I think denominator, everything is cancelled. Now here I have 23 into 22 into 21, 20 cancelled. I'll take 19 and then I have 3 and then 17, which is 490314. I don't think you will have to find this big number, not necessary. Next is 15C8. Here again write 8 numbers from 15, which is 15, 14, 13, 12, 11, 10, 9, 8. And then 8 factorial in the denominator. Cancel this. So 8 and 8 gets cancelled. 7 2s are 14 gets cancelled. 6 2s are 12. 5 2s are 10. 2 into 2 is 4. and then I have 3 3s are 9. Denominator, everything got cancelled. In the numerator, I have 15 into 13 into 11 and then into 3, which is 6435. So the answer is 490314 minus 6435. It is 483,87879. You don't have to find this big numbers. You can actually stop here. 23C8 minus 15C8 without actually, simplifying this and finding out the value. Is it clear? So what is indirect method? When to use indirect method? Only when you have at least one and the number of choices are too many. Number of subcases are too many. In the same question, suppose instead of inviting 8 friends, if he is inviting only 3 friends, he wants to invite only 3 friends. Out of that, at least one must be female. Okay, at least one is female. In this, you don't have to use the indirect method because he has to invite at least one female and he has to invite at least 3 of them. So it can be 1 female or 2 female or all 3 female. Only 3 subcases are there. Okay. So don't use the alternative method. Male is 15 and then he has 8 female friends and he needs to invite how many guests? He need to invite only 3. Minimum 1 female should be there, or 2 or all 3 females. If you have 1 female, then you need to have 2 men. If you are inviting 2 female friends, then he will need to have 1 male friend and 3 female friends means 0 friends. So this is 15C2 into 8C1. Okay, out of 15 men, you are inviting 2. Out of 8 women, you are inviting 1. So 15C2 is 15 into 14 divided by 2 into 8. This is 105 into 8 is 440. 105 into 8 is 840, sorry, 840. And here I have 15C1 into 8C2. 15C1 is 15 into 8C2 is 8 into 7 divided by 2 factorial is 2. So this gets cancelled. So you have 15 into 28, that is 420. Here 15C0 is 1 and then we have 8C3. So 1 into 8C3 is 8 into 7 into 6 divided by 3 factorial. 3 factorial and 6 gets cancelled. You get 56. And the answer is 840 plus 420 plus 56 is 1316. Here, don't use the indirect method. Okay. See how many subcases are possible. Based on that, you see whether you have to use the direct method or the indirect method. In this, the same question, we had 15 male friends, 8 female friends, and we need to invite at least one of them to be a female. But here we did not use the indirect method. We use a direct method because there are only 3 subcases. Okay, number of cases included are only 3. In the previous case, we didn't use here this one because we had 8 subcases, which is way too much to calculate. So what we did is we did one calculation, 23C8, which is total, and we found out how many female friends none of the female friends are included, that one. Only 2 calculations we did and we subtracted. That gives you the answer. Okay. When there are many sub cases, only then you use the indirect method.
वीडियो अच्छा लगा हो तो इसे लाइक और शेयर जरूर करें।
आपके लाइक्स और कमेंट्स हमें जल्द वीडियो बनाने को प्रेरित करते हैं।